day today outside. I can see that it's very sunshine today. We have 4 days of raining in BC here already. So I'm happy today to show you the video lesson today again. So in this video today, I would like to talk about the differential equation again, how to solve it, how to practice it based on the word problem. So before I get into the word problem, let me review some of the previous concepts so far we have been learning. So let's see. So everybody know that we have a differential equation y equals c e to the kt, and this we call the logs of natural log, right? In the past we have learned that. And then after that, you learn with me the Newton law of cooling, which is something like this. Temperature, derivative of T temperature minus surrounding temperature respect to time equal A plus T minus A C e to the kt, right? So this is we call Newton law of cooling, Newton's law of cooling. So today we'll get into the law of mixture, and all of that is just derived from this law, right? To allow us to solve the problem easily. Okay, so let me give you another concept. Let's say if you have a y derived function equal e to the x, then we know that the original function is the same, e to the x. Now if your y derived function equal minus k, e to minus kx, then your original function will be equal e to the minus kx, right? Everybody accept that. This leads to the same like if you have y right equal minus 3e to the minus 3x, then your y original function will be equal e to the minus 3x, right? So if you take derivative of this function, you get this. Basically, that's just that. And we already learned through the first course, which is how to take derivative of this exponential function, right? Derivative of this equal this, okay? So now this will allow us to say, if we have the y derived function with minus k to the e to the let call this is c, okay? C e to minus kx. Then of course our original function will be just c to the e, no, c e to the kx, right? Minus kx actually. Okay. So now let's see how, one more thing I want to go through with you, and that I call the important note, right? So basically, if you have y prime adding with ky equals 0, and this is the same, right? It's the same like you write, for example, if you have y prime plus 3y, it will be equal minus 3e to minus 3x plus 3e to minus 3x. So if you see something like that, if the people write like that, right? Then you know this is the left side, then the right hand, your right hand side equation will be plus 2e minus 2x minus 2e to minus 2x. This is your y graph, this is your y equals 0. Add together, that equals 0, right? So basically, if you have y graph plus ky equals 0, you can equate the equation. Your y will go minus e minus k e to the kx. And if your y graph equals c e to the kx, then your y will be equal c over k e to the kx, right? So all of that will be your equation. Okay. So after this is just the extra knowledge I taught you in here so that we're familiar with the pattern. If we have y graph minus 2y, we know that it will be equal to this. It's the same like y graph plus ky, where the k represents this number here, you will have this in general, right? Okay, so let's keep in mind all of this and let's get back into the question in here. Okay, so how we're going to do this question? Let me read the question to you and we're going to do this. So a tank contains 100 liters of salt water at a concentration of 15 grams per liter. Water containing 23 grams per liter of salt is pumped in at a rate of 3 liters per minute, and the mixture being steadily stirred is pumped out of the tank at the same rate. So the scenario like this, you have a tank full of water and the salt, solution of the salt in 15 grams per liter is a concentration of salt inside 100 liters of tank, right? Of the mixture of salt and water. Then water pumped in with the rate of 23 grams of salt per liter. Then it's stirred and then it pumped out and the rate of water solution of 23 grams, 23 grams salt come with the water in with the rate of 3 liters. They pump in with the rate of 3 liters per minute. So each minute there is 3 liters pump in the tank. And then water come out of the tank. But the amount of salt came out of the tank, we don't know how much. The reason because we know at the beginning we have 15 grams of salt per 1 liter inside the tank. And the tank has 100 liters inside. But the amount when we pump in and then stir equally and then pump out, we don't know how much salt came out. It could be 23 grams of salt came out or 19 or 12 grams per liter came out. We don't know. So that's the scenario. So let's see what the question they asked us. So the first question they asked, write a differential equation relating the amount of salt in the tank at the time t. Okay, so that's the first question. Second question, find the general solution of this differential equation. And then the third question, they will ask, find a formula for the amount of salt in the tank after 1 hour. And I think in missing, it should be shown for it, right? Okay. So this is the 3 questions. So first we have to establish a differential equation based on this scenario. So let's see how we do it. So I'm going to say given salt in the tank is 15 grams per liter. And how many water we have? And actually it's not water. the mixture, right? Or, you know, like a brine, because a brine is a mixture of salt and water, right? That's the name for it, a brine. A brine is 100 liter in the tank, right? And what else do we know? We know water in, water plus salt, right? In equal 23 gram per liter at the rate of 3 liters per minute. And then it pump out water and salt out is amount of salt we don't know, right? But also come out at the rate of 3 liters per minute. That's all we know. We don't know how much, and we want to find out how much salt came out. Now imagine if Newton and Leibniz did not invented for us the calculus, right? Maybe there's some way of calculating this using estimating or measurement or whatever, right? In chemistry, but it would be tough, right? It would be not accurate. But since we have a calculus, we can calculate it more easily and accurate as well. So let's see how we do it, right? Using the differential equation, solving it. So now I think the symbol is just 15 grams salt in the water, 100 liter. We can guess as well. We can estimate how much the amount of salt we came out, but it will be tedious task and it won't be accurate. So if we use a calculus, because we involve the rate of change, right? Because when the tide come in and we absorb the salt inside the solution and then came out with the timing and everything. So if we use a differential equation, the calculus method, we'll be able to calculate it more accurate, right? Okay, so let's see. So our task is write a differential equation. So what I'm going to do, I'm going to say delta A, right? The difference of the amount of salt respect to time over delta T will be equal salt in, the amount of salt in minus the amount of salt out, right? Let's put two concepts like that first. We have a water salt in and water coming out, right? Salt out, salt in minus salt out. The difference of them will lead us how much salt will be left over, right? That's the difference of the amount of salt. So I'm going to say let A be the amount of salt, be amount of salt, right? This is important. So we know our variable. Okay, so if we differentiate this, it will something like dA over dt, right? Will be equal, we will establish our salt in. Now we know that we have 23 gram per liter come in. So I'm going to write 23 gram over per liter. Time with the rate come in is 3 lit over per minute. Time with delta T, right? Depend on how long we pump it in as well, right? Minus time with the amount of salt. Let's call A for now. But remember, this A is not just A, right? So therefore, the ratio amount of A come out, right? A come out will be equal to A over 100 liter, right? Because remember, there's 100 liter of salt in there already, right? So when we're talking about the amount of salt, we have to count for this as well. So A divided by 100 liter time with the rate come out is 3 liter per minute as well. Time with delta T. So this is our first to establish, which is reasonable, right? The salt in is 23 gram time with 3 liter time with the time to pump in The sawn out is the ratio of coming out, A divided by 100 liter times 3 liters per minute times with the time pump out, right? So now we will have dA over dt, our differential equation. Let's simplify this. 23 times 3 is 69. Time with t, delta t, minus 3a, I put them together, over 100, time with t, right? So now let's simplify one more further. dA over dt equals 69t, or I can factor out the t because they look the same, minus 3a over 100 on of this time with the t. So that is the first differential equation we established, and this is answer for A. So that's our equation, okay? So now we go to B. Find the general solution of this differential equation. Okay, so we want to find out the general solution. We have to put back in delta A over delta T. So I'm going to solve the B like this. Equal. I'm going to split 69 back into 23 times 3 time with delta T. Okay. Minus 3a over 100 time with delta t. Now, why I do like this? I can cancel the lid because the unit will be gone. I cancel it, right? Now, if the t here equal minutes, then this unit up here and down here cancel out as well. As long as you have an up and you have a down, you can cancel, right? So 3 lit here, the lit will cancel with lit. So let us put on the number like that, okay? Except for the RAM unit here, it's not gone, it's still there, right? Everything here just cancel out. So, and we're talking about the amount of SON. So yeah, we left with the RAM unit, that's true. We don't have to put in the RAM unit right now. We just know that it's still there, right? Okay. On of the other unit, we cancel it. Okay. So now, what do we get? I'm going to put delta A over delta T will be equal. I'm going to factor out the 3 times delta T and the 3A 100 times delta T out. So I'm going to factor out this. Time with. Okay, so inside I have 23. Now I don't need 3 because I have 3 tie already here, right? So the 3 number 3 already here. So when I combine, I get that. Except that this 23 is just 23. It's not 23 divided by 100. When I pull out this ratio, I make this wrong. So to compensate for division 100, I tie back with 100, right? That's how I compensate for it. So I tie back with 100, I got 2,300. Minus. Now this already outside, right? 3 over 100A. So I'm going to put here, it's just A, letter A. On of this will time with delta T outside. So that is my differential equation. Why do I put it in this form? This is the general solution. This is the same like the derivative, right? This is the y prime derivative of the amount of A, dA over dt, right? It's the same like y prime, equal, remember we're talking about y. If we have a y prime equals ce to the kt, then there will be exist a function y equals ce to the kt. And that's why I want to put in this form, right? So we know this is our y function, and this is like a k value. You see, like y equal k value, and this our y original function. is equal to T, right? Respect to T equal this number. So now our function will be equal, it's like a Newton Coulomb area, remember the amount. So here will be the difference between the amount at A, the amount of sun, and the amount of sun at the beginning, A minus A0. So instead of T minus T0, or actually the other way around, right? T0 minus room temperature, right? Something like that. Remember Newton law? So instead of the temperature, this is a mixture. So the amount of A minus A0, right? Okay, so will be equal this. So I'm going to write this in this form. And I'm going to change the whole thing here, become C to the E to the KT. That's our purpose, because this is the function of Y. So remember, we just say if there is a derivative of this, then there will be an exit of the original function Y of this. That's, we just go through a whole formula, right? Just accept that fact, right? So now I can write this as A minus A0 equal C E. I'm going to change this, become KT. So our K, we have to figure out what K is this value, which is 0.03, right? 3 divided by 100 equals 0.03. So 0.03 times T, right? And if we want to move it over, we also can have this as well. So this is our equation at tablets, general formula, right? And this how we answer this is question B, all right? So this is the question B answer. We establish the general equation like this. So now we're going to solve for C. And how do we solve for C? So to solve for C, we know that after 1 hour, we're going to find out the amount of sun after 1 hour, right? So first we have to find out what to C here, right? So now solve for C. So we're going to say A equal A0 plus CE minus 0.003, just 10 T, right? So we know that at the beginning, at time T equals 0, how much sun, original sun we have inside the tank? We have 15 grams per liter and we have 100 liters. So inside the tank will be 1,500. We substitute this amount of sun, right? At the beginning. What is our A0 pump in? 0, right? At the beginning, we don't have any sun pump in yet, except this amount, right? That's for amount A. Adding with C, E. Now at time T0, everything here is just time with 0, so we can cancel that. So our C, wait a minute, let me see. At the beginning, we have at the beginning, water come in, contain 23 grams per liters come in at the rate of that. Okay, so let me see, do we account for 23 grams per liter when it come in? Yes, we do. So that is 2,300 because we're going to calculate when the amount of sun pump in at the rate of that when the time at water containing 23 grams per liter of sun is pumped in at the rate of 3 liters per minute, and the mixture being steadily stirred is pumped out of the tank at the same rate. Okay, so when we're looking for the C, our equation based on this equation. So yes, we have to account for the amount of 2,300 because we derive from this equation, right? So yes, we do have an A0 at the beginning, okay? So what do we got now? So for C, we get 1,500 minus 2,300 equals C. So C equal what? Minus 800. 1,500 minus, yeah, so minus 800. So our equation now become original function, the amount of sun equal 2,300 minus C E K T, which is the same like 2,300 minus C is 800, E to the KT minus 0.003 times with T. So now we want to find out after 1 hour, which is substitute T by 60 minutes, because 1 hour is 60 minutes, right? Will be equal to this, minus 800 E minus 0.03 times 60. T substitute by 60. So how much we get? So the amount of sun coming out respect to time, A of respect to time coming out, sun out, right, will be equal, let's do 800 power minus 0.03 times 60. So let's do 233 minus 800 power see. Okay, so we get 2,000. Okay, I'm doing it 3 times again. So I'm going to show you 2,300 minus 800 power. I'm going to put the E here. No, sorry. I'm going to do it again. 2,300 minus A, and then E to the power minus 0.03 times 60. I don't know, I forget to put the bracket. What's wrong with me today? Okay, so this is what I got from my calculator, right? I'm gonna enter it. Got 2,167. So we left with the amount of came out is 2,167.76. So let's round up like 2,168 grams of sun came out. So that's our answer for C. After 1 hour, we get the accurate about 2,168 grams of sun came out. Okay, so that is an interesting question, right? with a lot of work. So I don't know. It kind of like a little bit tedious task, but you see that if the mixture, and we have to measure and we have to calculate, and there's a lot of tedious tasks if we don't have calculus as well. So if we have calculus, it's also tedious like this, but also accurate, right? And it makes sense. If we don't have calculus, then I don't know. I'm not sure how we'll be able to calculate something like this. You measure 100 gram, 15 gram per liter, you calculate the time, how much is pumped in, and then you predict the amount came out after you stir the mixture. Well, either way, I think that is complicated because our life is complicated. So anyway, I hope you enjoy my video teaching today. I will see you in the next video, which is including the money, finance, how we use the calculus here, differential equation, to calculate money come in, money come out, if the rate of interest, how much, like 1.6% per year, and like something like that. So that it would drive you crazy. Anyway, let me stop our video here, and I hope that you will be able to follow all of this. So bye for now. See you soon.